Okay, have a look at the question and pause the video and do it yourself. I'm then going to show you the solution. Okay, so what you should have done is you should know this table practically off by heart by now. So by LDD, what does that mean? It means we want to go to address location 802. Okay, I'm here. Now what? Go inside. Get whatever's in there. Take it out with you and put it into the accumulator. And that is LDD. Load. Load the contents. Okay, so here's the next question. Pause the video. Give it a go. Okay. Uh-oh, I've covered this table. Never mind. Life goes on. So first thing we should know is that is LDX, not LDD. So what does LDX mean? It means go to address 800. I'm here. But then walk the following paces. And that is the amount of the total, shall I say, of this index register. So 1, 2, 4, 8. So if you convert this into denary, this is 9. So it's basically saying go to address 800 and then walk 9 steps further. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we arrive at 809. Get the value. And then put it into the index register. Sorry, the accumulator. And for the second part, how did we arrive at this? Well, I just say the steps of what I took. So totaled the contents of the index register. With the memory address location. And then be specific. 800 plus 9 equals 809. Boom. Okay. So before I begin, pause the video, give it a go yourself first. So we've got our trace table and we've got some instructions. Complete the trace table. Okay, so before I begin, I'm just going to look to see if I understand all of these as well as I could do. So we've got LDD, I know what that does, I know what ADD does, I know what STO does. STO, remember, will always store it back into this address. We've got a comparison. Because we've got a comparison, we've got 2 different jumps. So I need to know the difference between JPE and I need to know the difference between JPE and JPN. The beauty is that is why we've got this table for us. So we know that JPE is if something's true, JPN if something is false. Nice and easy. So I'm going to do true and I'm going to do false. We've got a jump, we've got an out, which means output, so print, just to remind myself. We've got an end and we've got some values here. Nice and easy so far, I hope. Okay, so let's have a look at the next step. What we're going to do is do this line by line. So LDD 800, so we've got 40, add 801. So what we're going to do is we're going to load 800 into the accumulator, which will be here. So in 800 we've got 40. We're then going to add 801. So we're going to take 50 and we're going to add it to the 40, which gives us 90. We're then going to store the results of that into 802, which is here. We're then going to load 803. We then are going to do a comparison. Compare with 802. So comparing what's in the accumulator with 802. Do they match? Yes, they do. Because they match, I'm going to jump to 107, which is here. This is the jump. I could have done these arrows actually as well beforehand. STO 802, so store this into 802, which is going to be here. We're then going to output, and we're going to output whatever's in the accumulator. And I'm going to put it here. We're then going to jump to 112, and it ends. That's it. If you put it here, I'm not going to lose too much sleep about, but it will be on the next line because it's basically saying the next step. Okay. There's one more question, I believe. So this question is saying we've got a redundant instruction which doesn't need to be there in this code. We need to find the address. Well, that will run, that will run, that will run, that will run, this will run. Jump to 107, so I'm going to do my arrow to 107. So this will run. I know that 107 will run. 106 could run. Jump to 110. Okay, so I know that all of these could run, which is absolutely fine, but let's have a look at what isn't actually needed. So if we base it back on our previous question, what was it that we didn't actually need to do? So let's show the solution back again. So let me just quickly fill out this table. So we had 40, 90, 90, 90, 90, Z. So we know that all of this runs. So what else is going to make it redundant? As in, what don't we need? Well, if you have a look at this table, especially this area here, what do you notice? What we're simply doing is placing this 90. So we're doing this in a way. This is redundant. We don't need to put 90 back into address 802 because it's already there. So where does that actually happen? Well, that actually happens here, where we're storing whatever's in the accumulator in 802. It doesn't need to be here. If we took this out, so let's imagine, let's just undo some things. Let's imagine that we didn't have this bit. So we compare right here. We compare here, sorry, 802 with whatever's in the accumulator. Do they match? Yes. So jump to, let's jump to 108 now. So let's change it to 108. Output. There. It's the same as basically if we did this. So this is actually not needed. It makes no impact on the program. It just means it runs a bit slower.